Who of you is familiar with Varnish? I guess all of you, basically, yeah. Who of you has been using Varnish so far? About half-ish. Yeah.
Does it being installed for you consider you using Varnish?
It does.
So
I thought, since at Freisebox we are using Varnish heavily, I'll simply go over the things Varnish does and how it does it, and give you a few tips on the way how to get the most out of it. So just to cover the basics, Varnish is a reverse HTTP caching proxy, which means it takes incoming HTTP requests from the website visitors, processes them, and so the proxy, it passes them on, in that case, to a Drupal server. What it does in between is to cache all the content that comes back from Drupal in response to these requests. And if the same content is requested again, Varnish will be able to serve it directly back to the visitor from its cache. And to be frank, Varnish is one of the best pieces of software engineering I've seen in my life. This thing has amazing performance. So due to its caching, it'll be able to serve hundreds, if not thousands, of requests per second, which a Drupal web server normally isn't, with all the baggage it has, with all the things it has to do. The only thing Varnish has to do is, to put it simple, take the request, make a lookup. Do I already have the content for that request? Yes, I do. Serve it back. Done. So, for example, we have a customer. They have about 1 million followers on Facebook. And as soon as they put a link on Facebook to their website, which they do, I think, every 2 hours, so you can calculate yourself, if of that 1 million followers, only 1% clicks that link within the first 5 minutes. That's a lot of visitors to the website. What they do, thanks to Varnish, is run the website on a single mid-sized server. Because Varnish serves in average 500 requests per second of website content that's already stored in the cache. And only if people use the voting mechanism on the website, requests go back to Drupal to process that vote. So Varnish can make a little server look blazingly fast. Varnish also does load balancing, so you can put more than one server behind it, and it'll automatically distribute the requests on these servers. High performance, I've already covered that. The Varnish developers intentionally did not build in any SSL encryption, so if you need to cache encrypted traffic, you will need to put an SSL offloader in front. But that obviously enabled them to focus on the core thing, and that is serving content quickly. What Varnish also does, and that becomes important in a minute, is it avoids the thundering herd problem. If you have content that isn't yet cached, and a lot of people are requesting that content at the same time, instead of directing all these requests back to the backend, it only does that for one request. It stores all the other requests, keeps them stalled, then content comes back, and then that content, if it's cacheable, will be served to everyone. So instead of have all these people go back to the backend because the content hasn't been cached, it saves the backend from overloading. The way it's doing its caching can be completely controlled by an own programming language which they call VCL. It's based on the syntax of C, and enables you to make completely custom changes to how varnish behaves in certain situations. So, as a first tip, if you install varnish, choose a few sane settings for cache memory. That's of course the main, most important thing. Having a few hundred megabytes of cache also already does wonders. And of course, if you have a big website, you will probably need more. We have a customer that has 4 gigabytes of varnish cache and still runs out of cache. So still things get put out of the cache because newer stuff needs to get into it.
Jochen, is cache memory, is that disk space or is that RAM from the server?
It can be either, but obviously memory is better. But for example, if that customer that I just mentioned said, I want everything cached, and I can't provide him, assume we can't provide him with 40 gigabytes of RAM. There's an option to use disk space as cache, but that won't be as fast as memory, obviously. Yeah, if you have got any questions, please feel free to ask. There's a lot of settings, and I've only picked 3 of them that are connected to the threading that varnish does so greatly. You can say how many thread pools varnish has, and when I started with varnish, I thought, okay, I'll use a thread pool for each core my machine has. So, for example, if you have a quad-core machine, you can use 4 thread pools that can then be processed by each core. As it turns out, that's overkill. Thread pools has a default of 2, and that's enough for even the biggest websites. And thread pool min and max then determine how many threads per pool you have from the start to be ready to serve content, or max as an upper limit. So you can start with, for example, say, okay, I'll always keep 10 threads around waiting for incoming requests, and if traffic increases, I'd like to limit my resource usage to, for example, 100 thread per pool. So if you have a thread pool setting of 2, it'll be 2 times 100 threads, for example. You might need more, but don't overshoot. It'll eat up your memory quite quickly. So let's look at the caching logic. That's the main strength of varnish, that you can completely customize how it works. To understand varnish better, we need to go through the different phases of communication with the cache and with this proxy. There's a function that's called VCL receive. That comes in when a request arrives. At that phase, you can analyze the request, can see what HTTP headers the request has, what content is to be served, so for example, the URL that's requested and things like that. And based upon that, you can make decisions on caching policy. You can decide which backend, so which web server the proxy should forward the request to. And you can do things like access control. You can say, okay, for that URL, I'll only serve to certain IP addresses or things like that. Or a lot of other things. So what's served as well are a few different things at that phase. First is enable grace mode. What Varnish calls grace mode is simply a way of extending cache lifetime. Your web server, your Drupal installation will determine how long things are allowed to linger around in the cache. You do that by sending expire HTTP headers or cache control HTTP headers, where you can say max age equals, for example, 300, which is 300 seconds or 5 minutes. And after these 5 minutes, things will get taken out of the cache, obviously, and if they are requested again, Varnish needs to ask Drupal again for that content. What if the backend at that time isn't available, if your server is overloaded, or if there's some network congestion or things like that? You can tell Varnish, okay, I'd like to extend caching lifetime, for example, by a minute or something. And during that time, Varnish will still be able to serve stale content out of the cache while it tries to reconnect to your web server. So that enables you to cover up short downtimes in the backend. Then drop unnecessary cookies. Cookies are the arch enemy of caching, of course, because they signify individual content, which per definition can't be cached. So if you have JavaScript things on your website that generate their own cookies, or if you have modules that create their own cookies, you can drop these cookies in the receiving phase, or you can, for example, say, okay, the visitor sent me a cookie. He obviously has some kind of session with my website, but they only requested an image file, and that image file is from the public asset directory under sites default files, so it's the same for everyone anyway. And in that case, you can simply throw away that cookie, enable that image to be cached, and serve it for every visitor, regardless if they send cookies or not. So that enables you to, for example, get Drupal 6 websites a lot more performance. Drupal 6 makes sessions for each and every visitor, so it creates cookies for each and every one, and basically disables caching at all. By dropping cookies for static files, you can at least get these cached at that stage. And what you can do, you can also do the opposite. You can say, okay, there are certain URLs that I don't want caching at any time. For example, AJAX requests, OAuth requests, things like that. Even if they don't send the right headers that would prevent caching in the first place, you can add that to your caching logic and say, okay, if someone requests something that looks like /AJAX/something, I'll pass the cache in any case. When Varnish puts things into the cache, it obviously needs to do some mapping between the request and the cache content, and that's what VCL hash is for, another function. And it defines what is unique about a certain request. And in that phase, it makes sense to not send a vary user-agent header, because that means content should be considered as unique for each different user agent header that comes with the request. So for each browser version that content is requested, it gets its own unique cache content. That's obviously really bad for performance, and you could decide to say, okay, if there is a very user agent header, I'll simply drop that header and say, okay, I don't care with what browser and version that stuff is requested. I simply serve the same content for each and every one.
So does that mean that you basically won't get a responsive site then, if you've written a site to vary on?
Oh, that's a fair question.
You mean if you're using something like mobile tools in Drupal, is it?
Well, anything that's going to have, it's going to have serve different, say, theme settings, or it's a different CSS up depending on what the user agent is. So you say the first person who requests the page is on a mobile device, and the second person is on a desktop machine. Are they going to get the mobile? Second guy going to get the mobile one that's cached?
Good thinking. Yeah, I think that could be the case actually. Yeah.
They do.
I'm not front-end
They do.
developer enough to say that with confidence, but
That's what happened. Well, we used Varnish and we used mobile tools, and we're using mobile tools. I was Varnish on Pantheon, and we installed Pantheon, and then it just was like if people were coming on desktop, they were getting the mobile style sheet.
So, but if you had a responsive style sheet, obviously that's already on the client. That'd be different. But
that
it's
was
coming from the server. Yeah.
It was because we were using mobile
Mobile
tools,
tools,
and I was browser stuff on essentially, so we just stopped and just went to full responsive
Fair enough. Okay.
and used Varnish because performance it was more important, it was better too.
Yeah, it makes sense. So I take that back half a step, saying be conscious of what you do with Varnish. If you need certain things, for example, if you need that fine of a differentiation, or if you don't need it. And if you don't need it, simply get rid of these things because they cost you performance. Obviously, if you need them, you can't take them on. Then there are two small functions, hit and miss, that are called depending on if there's a cache object for that request or not. You can do different things here as well. Is there something of a lot of interest? Yeah. No, not really. These aren't that important. Resale pass is if you decide, or if the cache decides to pass the cache, for example, if it sees a cookie or something else that makes the request individual, it'll call resale pass. You can do different things here as well. Resale fetch will get the content back from your Drupal server. You can make some cleanup to the request there. You can decide to use different expiry times than Drupal told you to use, or tells the cache to use. And there's an interesting thing that Varnish offers here. It's called hit or pass. So that comes into play if your Drupal server delivers an error. For example, request comes in, gets passed to Drupal, takes 2 seconds to respond, and what comes back is an error, server error or something like that. Obviously, you don't want to have that cached for 5 minutes. If the backend recovers within seconds, you'd like to be responsive again. So you can't cache it. But if you now have a lot of requests for an uncached object, as I told you before, they get held until the first request comes back. So it takes 2 seconds. The first request comes back with an error. Now what Varnish would have to do is to say, okay, I can't cache that, so I need to pass the other 100 requests that have been waiting also to the backend. So it'll take the next request, pass it to the backend. It'll take 2 seconds to respond with an error. The error gets back, served back to the visitor. Next one. And since it always takes 2 seconds for the error to come back, people will be waiting forever. So what you can do is store a hit for pass, which is an entry in the cache that says that content is not to be cached. What it does is it'll not stall everyone, all the 100 people that request, hoping there will be a cacheable response. Since there is a hit for pass object here, it knows there won't be a cacheable response, and it'll pass everyone back to the backend. I don't think that'll help an overloaded server in that situation, but at least they get back their server error in that case immediately, instead of waiting for 12 seconds or something like that. Obviously, you'd like to modify the lifetime of that hit for pass object. So you can say, okay, something went wrong. I'll store that hit for pass object for a minute or something. Everyone gets put through to the backend immediately for a minute, and if things get better, we can hopefully start caching again.
So you couldn't show the stale content.
If there is stale content, it'll be served. That's what the grace mode does.
So
But in the case you don't have any cached content, you don't want to have Varnish do its normal thundering herd avoidance program by stalling everyone, if you can assume that everyone will get an error anyway. So, and at last there's VCL deliver, which actually delivers the content that was fetched back to the visitor. And you can do some additional things here as well. For example, what we do is we actually do it in fetch, add a few additional HTTP headers that identify from what backend the content came, and other things as well. There's also things you can do on the application level. For example, what we highly recommend is use far future expiration, which means provide your content with as big of a lifetime as possible, maybe even days. So you can serve content saying, okay, that content is allowed to be cached for a day or 14 days. Actually, the default setting in Drupal's .htaccess file has a setting in there that says content can be cached for 2 weeks. We had lots of support requests of people wondering when their theme change would take place. And I told them, okay, it'll be 1.5 weeks from now. You've already waited for 5 days.
Jochen, what does that do on a page that has comments? Does the content get cached and the comments not get cached? Or
On what?
say you got a page, a blog post, and there's comments under the blog post, and you cache the blog post because you're not going to change the content.
Yep.
But you want the page changing every time someone comes through to see new comments.
Yeah, that's the second part of far future expiration. Of course, you'd like to have your content as cached as long as possible, but things will change. You will put up a new blog post that you'd liked in your list of blog posts. There will be a new comment added, and you'd like to display that as soon as possible, especially to the one who wrote the comment.
Yeah.
So what you do is a controlled cache expiration. You don't work with with assuming, well, I think 10 minutes or so might be a good middle between fresh and stale. So I send my content with a max age 300. Maybe 5 minutes is not okay. I need 10 minutes, so max age 600. You always, with these expiry times, you always need to make some kind of assumption what will fit your visitors. With that method, you say, by default, I'll cache everything for weeks. But as soon as something changes with a certain content object, I'll tell Varnish to forget about that, and only that. There's the purge module for Drupal, which enables you to do exactly that. And you can combine that with rules to say, okay, if someone adds a comment to that node, purge that cache entry for that URL.
Okay, yeah.
And it'll get taken out of the cache. Everything else still lives on for weeks. That particular content object will be taken out of the cache and refreshed as soon as it is requested again.
Is it possible? Sorry.
Does the far futures expiration not just apply to static assets? Like it doesn't apply to HTML pages?
It can apply to everything.
No, but in the Drupal.htaccess file.
Yeah, since it's in the htaccess file, it only concerns things that will be served by Apache itself, which are static assets. There's another setting in the htaccess that says, okay, if I can find it on the file system, don't even involve Drupal, simply serve that. So that applies only to static assets. But for example, parts of themes are static assets, so that will apply there as well. And so in that case, a customer support request comes in and customer wonders, I've changed things 2 hours ago and it still doesn't show. We first thought, well, that's because of that expiration setting, it doesn't make sense at all. But if you take it that far and adding controlled cache invalidation, it actually makes sense to store things that long.
Jochen, is it possible then to cache page sections? Like you could say the header is not going to change for 5 months because we got our logo and we've got our Facebook link. That's all we need in the header.
Yeah.
I can cache just the header and just the footer and leave other parts dynamic.
That's a perfect explanation for ESI, Edge Server Includes, where you simply do exactly that. You structure your page into different parts, and each of these parts can be cached independently. So you have something, you first serve some kind of HTML page that has a certain kind of include statements for, it's a bit like frames in that case. And that enables Varnish to request these parts separately, and you can apply different caching policies to each part. So that's exactly what ESI does.
Okay.
And it makes it possible to say, okay, the only thing that changes on my pages is that certain block. Everything else is far or less more or less static. And with ESI you can optimize your caching for that.
Do you have many clients using that?
No, we don't.
Do you have any clients using that?
I'm not aware of any. That doesn't mean there isn't any, but at least if there are any, they haven't yet any problems with it, to put it that way. We didn't hear of
I
them,
asked
so.
because, I've seen people look at it and the performance gain of just generating a single part of Drupal wasn't sufficient to go for the setup.
Yeah.
At least not in Drupal 6 or 7.
Mm-hmm. Obviously, you have a lot more requests to serve than if you cut your page into, for example, 4 different sections, left and right, top and bottom, and the main content in between. These are now 5 requests instead of 1 to serve that content. And that will generate an overhead, and we need to determine if that's worth the performance gain, if there is any. So use the purge module and probably the expire module to control your cache invalidation, and you can use caching lifetimes, not only 5 or 10 minutes, but even weeks.
Sorry, Jochen? Yeah. If you've got a page and you're not splitting it up like we just described, and basically, so the whole thing, say you have a sidebar that has recent comments or something, so it's going to have to, probably not going to be cached very long.
Mm-hmm.
But you do have images which would be cached. Is that much of a saving over using the Drupal cache for the same thing? Just basically, you're just caching images and video embedded stuff, you know?
Yeah. Since Varnish really has 1, 2, maybe even 3 orders of magnitude higher performance than any web server I know of, it makes sense to put as much into the Varnish cache as possible.
So even just do it just for like,
yeah,
this is the multiple
and
requests.
since these are separate requests anyway, your images as defined, CSS, JSON, JavaScript, different from separate from the HTML, it will be cached automatically. And for images, for example, it really makes sense to store them for a long time. Okay. Now let's get to the final part, operation. If you use Varnish, it makes sense to monitor certain key performance indicators. There's, for example, a command line client for Varnish, which is called Varnish Stat, that lists a huge number of metrics that can show you how your Varnish cache behaves, how efficient it is. Obviously, cache hit and cache miss are the most important values here, so you can see the hit to miss ratio. And for example, with the website I mentioned with the million Facebook followers, they have a hit rate of more than 99%, and that's how they are able to use a relatively little Drupal server with hundreds of requests per second. Neither Apache or Nginx would be able to serve that in that time. But then there's also the more negative metrics like backend fail or backend too late, things like that signify how Varnish has problems getting content from your Drupal. So you might run into problems there if your backend isn't able to cope with traffic. And in terms of cache size, you should look at the LRU nuked value, which means least recently used nuked. So things that aren't used much, aren't requested much, and therefore get thrown out of the cache in order to store fresher content. If that number keeps increasing, it tells you that your cache size is too small for the amount of content you are serving. Obviously, there are additional tools that also generate graphical representations of these values. For example, there's collectd or other tools that will make nice graphics out of these values, so you can see, does my cache efficiency actually increase with the changes I do, or does it decrease? You don't need to use command line tools for that. And then take a look at the syslog from time to time, because if there are any problems that Varnish has launching new threads or managing these threads, it'll log them to syslog, and you'll see if, for example, a child process got killed and needed to be restarted again, and things like that. All right. Any further questions? Obviously, I didn't do a deep dive in that short time, but I just wanted to give you a short overview of how Varnish thinks and at which point you can make what customizations.
How do you get at the VCL stuff to do the customizations?
It's a simple file. It's basically a text file that you can edit, and then you simply reload Varnish, or you reload Varnish. You even don't need to restart it, but only issue a reload, and then it'll parse the new logic. It actually has a C compiler built in that is probably responsible